All right, today's video is to show you some of the bonding basics for ionic bonds. We need to kind of look at the periodic table of elements first and note that there are two categories. The periodic table is broken up into metals and it's broken up into nonmetals. The metals are located to the left of the bold staircase and the nonmetals are located to the right of the bold staircase. So if you take out your periodic tables that we've given you, the bold staircase that I'm talking about is towards the right side here. This big bold line is the staircase. So if we're looking at elements that are on this direction, we're looking at metals. Elements that are on the right side here are nonmetals. So that's how we differentiate between nonmetals and metals on our periodic table. Going through and applying this to our notes, ionic bonds are formed when metals and nonmetals come together. So it's a bond between metals and nonmetals. And this forms when electrons are transferred from one element to another element. So metals will actually tend to lose valence electrons, and the nonmetals are going to gain valence electrons. This is the pattern we see for every ionic bond. Their goal is to complete their outer energy levels and have a full valence shell. And for most elements, they want 8 valence electrons. So if we look at sodium and find sodium on our periodic table, sodium is over here in group 1. We label our group numbers again. Okay, group 1 has sodium. So because it is in group 1, it has 1 valence electron. It was to the left of the staircase, which means it's a metal. And if we look at our notes here, metals will lose electrons. So because it's a metal, it's more likely to lose electrons than gain them. Chlorine is our next element that we're looking at in our notes. Chlorine is over on the right side of our periodic table in group 7. So if it is in group 7, it has 7 valence electrons. Because it's to the right side of our bold staircase, it is a nonmetal. And because it's a nonmetal, it is going to gain electrons. Okay, looking at this rule again, metals will always lose electrons, nonmetals will always gain electrons. Magnesium is in group 2, which means it has 2 valence electrons. It's to the left of the staircase, so it is a metal. And that means that it is going to lose electrons because it is a metal. Iodine is in group 7, so it has 7 valence electrons. It's to the right of that bold staircase, so it is a nonmetal. And that means that it is going to gain. Once again, nonmetals will always gain valence electrons. The last element in our table here is helium. If you were to find helium on your periodic table, you would look at it and notice that it is in group 8. But if you remember, helium is one of our special elements that has some of the rules that are not consistent with what we see in other elements. It's in group 8, but it only has 2 total electrons, and it has 2 valence electrons, but those 2 complete a full outer shell for it. If you were to form a Bohr model for it, it only has 1 energy level, and that energy level holds 2 valence electrons, so it is full. So even though it is a nonmetal, it is not going to gain or lose any, okay, because it is in group 8. Group 8 elements are unreactive. So all of the elements that are forming ionic bonds are in groups 1 through 7. They are not in group 8. Group 8 is unreactive. So we're going to take this information and start applying it to see how elements come together to form ionic bonds. The first combination of elements we're looking at is sodium and chlorine. So if we were to bond sodium and chlorine, we're first going to model it by drawing a Lewis dot structure for each. So I'm going to draw my sodium Lewis dot structure, and its symbol is Na. And because it's in group 1, it has 1 valence electron. Chlorine is Cl. And because it is in group 7, it has 7 valence electrons. You would notice that we have 3 pairs of electrons on chlorine that are already paired up. However, there's this one space that is an unpaired electron. If we think back, all electrons or all atoms want to have 8 valence electrons, and so chlorine only has 7. It has this one unpaired electron, so it needs an electron to fill it. So what is going to happen as an ionic bond forms is sodium is going to give up this 1 electron, and it's going to be given to chlorine and fill in that gap so that chlorine has a full valence shell and 8 valence electrons. Because sodium is losing this electron, it's losing a negative charge. In neutral atoms have the same amount of protons as they do electrons, canceling out and making sure that they are neutral. Because we are losing one of our negative charges, we are left with more of a positive charge. Because we're only losing 1 charge, we are positive by 1. We have 1 extra proton in sodium than we do electrons. So sodium now has a positive 1 charge. Chlorine has now gained a negative electron. So now it is negative by 1 because it has 1 extra electron than the protons that chlorine has in. When we're looking at writing a chemical formula for how this ionic bond has formed, we need to account the number of atoms that are involved in it. So we have 1 sodium atom. Sodium we have 1 of. And then for chlorine, we have 1 chlorine. Can't spell. We have 1 chlorine atom as well. So when we are writing chemical formulas, we are going to actually merge the atomic symbols. So we are going to put the metal first. So it is NaCl as our chemical formula. Because we have 1 of each, we are done with our chemical formula, and we're actually done looking at how this bond is formed. Our next example that we're going to do together is magnesium and iodine. So if we were to start by drawing a Lewis dot structure of each, we can start looking at how they are going to bond together. So we're going to start with magnesium. Magnesium's atomic symbol is Mg. Because it is in the second group, it has 2 valence electrons. And if we were to draw iodine, iodine is also in group 7. So it has 7 valence electrons. Okay, similar to chlorine, iodine has 1 unpaired electron, and it wants to get 8 because that's kind of the magic number that atoms want to have. Magnesium has 2 to give up. Iodine needs 1 of those 2 to get to 8. So the bond that they're going to form is a little bit different than our first one. Magnesium is going to give up 1 of its electrons and fill this gap of this iodine atom. However, it has this extra electron that it also needs to give up. So if you run into a bond where one of your atoms has a full valence shell and the other one does not, or it has extra that it needs to give up, you need to keep adding atoms in order for all of the nonmetals to have given up all of their electrons and all of the metals to give up their electrons and nonmetals to fill in their valence electron shells. So because we have one extra to give up, we need to draw another iodine atom. So we're going to add another Lewis dot structure for iodine. We have another gap here to fill. So this magnesium atom's other electron is going to fill in that other gap. So it takes one magnesium atom to bond with two different iodine atoms. So we have a different ratio in this bond than we did our first bond. So when we're looking at our chemical formula and counting our atoms, we have, once again, a different ratio. For magnesium, which is our metal, we have one atom. And for our iodine atom, our nonmetal, we have two elements, okay? And the reason I'm adding two is because we have one Lewis dot structure of iodine here. We have another Lewis dot structure of iodine here, representing that we have two iodine atoms. So our chemical formula has a little bit more to it in this one, representing both of those atoms. Our metal always goes first, so we are going to write our element symbol of magnesium, and then we're going to write our element symbol of iodine. However, we need to represent that there are two atoms of iodine, so we're going to add a 2 as a subscript after the I for iodine, showing that we have two of these elements. So once again, this atomic or this chemical formula shows that you have one magnesium atom bonding with two iodine atoms. We're going to do one more example together. Before we do that, we'll just kind of recap our charges on magnesium and iodine. Iodine is similar to chlorine. Each iodine atom has gained one electron, so they are negative, and they have each gained one. So they have one extra negative charge, making them negative with 1. Magnesium has a slightly different charge. It's positive because it has given up negative charges. So it's left positive. However, it has given up two negative charges, leaving it positive by 2. So if it has more protons than it does electrons, it's positive. Because it lost two negative charges, it has those two extra protons than it does electrons. That's where we're getting that positive 2 charge. So our last example that we're going to do together is on the back of your worksheet, and we're going to show how sodium and oxygen form a bond together. So we are going to draw a Lewis dot structure for each. Sodium, once again, is Na, and is in group 1, so has 1 valence electron. Oxygen is our nonmetal. Oxygen is in group 6. So oxygen has 6 valence electrons. Okay, and if we look at oxygen, we actually have 2 unpaired electrons that we need to fill. Now sodium has 1 that it's willing to give up. So sodium is going to give up its 1 electron and help out one of the pairs for oxygen here. Because it gave up an electron, it now has a more positive charge, and it's positive by 1 because it lost 1. However, we still have this extra unpaired electron that needs to be filled in order for oxygen to have a full valence shell. So to fill it, we actually have to have another sodium atom bond with it. So similar to how we did in our example above here, magnesium and iodine, we had to add 1 more atom in order to get rid of both of the magnesium valence electrons. We kind of need to do the same thing here. So oxygen needs 1 more, so it is going to bond with 1 more sodium atom to fill in this other unpaired electron. So each sodium atom now has a positive 1 charge. The oxygen atom now has 2 extra negative charges. It has gained 2 electrons than what it would typically have. So it is negative by 2 charges. So they have formed charges, and that's kind of why they're called ionic bonds. They're forming ions here.